Today we're going to talk about the errors that can be made in conducting a hypothesis test. So at the end of a hypothesis test, using a p-value and comparing it to an alpha level that we've accepted, we're either going to reject the null hypothesis or we're going to fail to reject the null hypothesis. And the truth of the matter is that we can't be 100% sure that we've made the right decision. All we can do is make a decision based on our evidence, based on the sample we've taken, and the calculations we've made. So a couple types of errors arise. There's two types, appropriately named a type 1 and a type 2 error. So this is an important chart to have. It'll help you. Our null hypothesis can either be true or false. What we can't know is if it actually is true or false. So a type 1 error is an error that arises when we reject the null hypothesis, even though in reality it's true. So that's a type 1 error. If we reject the null hypothesis and it's actually false, then we're okay. There's no error made there. We made the right choice. Again, we don't know that we made the right choice. But if in fact those two things line up, then we're okay. If we fail to reject the null hypothesis, even though in reality it's false, we've made a type 2 error. So let's think about this in terms of the justice system that we started talking about at the beginning of hypothesis tests. So our null hypothesis was they're innocent, and I'll type that out. And so then our alternative was that they're not innocent. We call it guilty, but I want to be consistent with our hypotheses. So a type 1 error in this scenario would be us convicting somebody, meaning we reject the null hypothesis that they're innocent, and we convict them of the crime, even though in reality they were actually innocent. Okay, again, there's no way for us to know that they were innocent. The jury has to use the evidence at hand to either reject the null or fail to reject it. So if we reject their innocence and they're actually truthfully innocent, that's a type 1 error. A type 2 error would be us failing to reject the null hypothesis, concluding that the person was innocent, even though they were not. So basically, a type 2 error is letting a criminal walk free. A type 1 error is putting an innocent person in jail. So we can figure out the probability of committing a type 1 error, and that's just by using our alpha level, that fishy, the significance level that we use to either reject or fail to reject the null hypothesis. Because a type 1 error happens when you reject a null hypothesis that's true, our probability of making that error is that alpha level. So let's say our alpha is 5%, so 0.05. That means that if our p-value is less than 0.05, we'll reject the null. That 5%, that's the probability of rejecting the null when we shouldn't have. We use the Greek letter beta to represent the probability of committing a type 2 error, and this is not something that we can really calculate because we actually need to know what the true proportion is, and we don't. Alpha and beta are directly related. So if we increase alpha, if we increase the probability of making a type 1 error, then we're going to reduce the probability of making a type 2 error. Okay, it becomes easier to reject the null hypothesis if we have a large alpha. We can talk about the power of a hypothesis test, and that's the probability that we correctly rejected a false null hypothesis. So take a second to stop writing. Let's go back here. If we reject a false null hypothesis, we're okay. If we fail to reject a false null hypothesis, we've created a type 2 error. So essentially, we're letting an innocent person walk free. So in terms of the justice system, the power of a test is the ability to convict somebody who's guilty. And so that power is the percentage of not making a type 2 error. So if beta is the probability of making a type 2 error, 1 minus beta is the probability of not making that error, and that's what we call power. Again, we're not really going to be able to calculate this because we don't know what beta is. This is sort of a theoretical conversation. We can also talk about the effect size. And basically what that is that is the distance from the null hypothesis, so that p-value, p0, that we are accepting as the real proportion, and p, which is the actual true proportion that we can't really know. So the further they are apart, the greater the effect size and the greater the power of our test. So again, some of the conversations about these phenomenon are a bit theoretical. So this diagram is in your book. I wanted to highlight it a bit and discuss it. This P0 here is our hypothesis value, and this is a normal distribution for the probability that the null hypothesis is true. Down here we have a normal distribution for the probability that the null hypothesis is not true. And so we get this section, this right tail, the percentage that the probability that the null hypothesis is true and we reject it, making a type 1 error. This left tail is the probability that the null hypothesis is not true and we fail to reject it, making a type 2 error. This p-value is the true value. This p star is the proportion that we get from a sample where we would reject the null hypothesis. So if we look at this diagram and we move this vertical line, if we move it to the left, we'll increase the probability of making a type 1 error, but will decrease the probability of making a type 2 error. If we move it to the right, we decrease the probability of making a type 1 error, but we also increase the probability of making a type 2 error. So what we will hope to do is get the balance right here so that we can limit the error that we make. I also want to highlight here the effect size. That's the distance between P0, our hypothesis value, and the actual p-value that exists that we, again, don't know. So if we were to create a bigger gap here, if we were to pull this bottom distribution to the right, creating a bigger effect size, you would see both types of error reduced. And the way that we can do that is by increasing the sample size. If you increase the sample size, the variability decreases, our distributions become more narrow. You can see that these curves are a bit more narrow than the ones on the previous page. And so the tails, the right tail up here and the left tail up here, become smaller, meaning that the probability of making an error is smaller. Okay, so just like when we did confidence intervals, to reduce the margin of error, we have to increase the sample size. So here, to reduce the probability of having an error, type 1 or type 2, we have to increase the sample size. So a lot of that conversation was a bit theoretical, but but we can look at a scenario and know what type of error we could potentially make. And so we're going to practice that a little bit. Remember, making a type 1 error is that we've rejected the null hypothesis when we shouldn't, and a type 2 error is we fail to reject when we should. So if you go to your book, page 536, number 7, we'll go over the answers. So in part A, you can see there's a null hypothesis of p equals 0.3. The alternative is p is greater than 0.3, and they've rejected the null. Later, they find out that the actual percentage is 28%, which is actually not greater than 0.3. So the error we've made here is a type 1 error. They rejected the null hypothesis, said there was evidence to show that the proportion was greater than 0.3, and then later they found out that it actually wasn't greater than 0.3. In number 2, they tested a null hypothesis of 0.5. So if there's no difference in who prefers Coke or Pepsi, the null hypothesis, the proportion will be half like Coke, half like Pepsi. The alternative would be that there's some sort of difference. The students prefer one or the other. So they failed to reject, meaning they're accepting that there is no difference, and later on they do a test to find that there is actually no difference. So they did the right thing in failing to reject the null hypothesis. So go ahead and pause right now, and I want you to try C on your own, and then we'll discuss the answer. So in C, they made a type 2 error because based on their p-value, which was really high, they decided to fail to reject the null hypothesis. So they're accepting that the headache relief rate was 25%, and then they did some further tests and found in a different hypothesis test that it actually relieved 38% of headaches, which is bigger than 25%, which says they should have rejected the null, and that is a type 2 error. So please, right now, if you have questions, if it's a bit confusing, that's okay. The chart at the beginning is really important in determining whether you've made a type 1 or type 2 error. Again, a bunch of this was pretty theoretical. We're going to do some practice together in class. Come ready at the beginning of class to ask me some questions, and we'll work through it together.